Okay. Yeah. So the last week we have discussed about this linear PDE, quasi-linear PDE, some of the problems. So also we have derived the transport equation and perverse equation. Now what we are going to solve is that we are once again going to solve this perverse equation ut plus ux equal to 0. Okay, but there are the initial conditions also we have. Okay, the initial condition gamma and alpha. Now what I am going to do is that again the initial condition I am going to give, okay, because it's a time different problem. So we have x comma 0 I am going to give. So I'll be considering two problems. One if x is less than 0, and two if x is greater than 0. This is one type of problem. Another initial condition is this one. You have x comma 0 equal to 2 if x is greater than 0, 1 if x is less than 0. Okay. So these two types of problem we are going to discuss. Okay. So it means like what I'm this is a discontinuous. The initial condition is not continuous. It's a discontinuous problem because at x equal to 0, the value we are going to get some kind of discontinuous going to come, because at very near to that x equal to 0, you get either 1 or 2. So means we are going to get some problems. Okay, so therefore we are going to solve that problem. Okay. So now let us solve these two problems. Okay. So first problem, let us solve rarefaction problem. So what is rarefaction? Okay, let us solve this problem once again, which we have solved already. So first let us take this problem. You have x comma 0 equal to 1 if x is less than 0, 2 if x is. So what is the characteristic system we know? So the characteristic system is nothing but dx by dt, dx by ds equal to, because already t is a variable here, so I'm just making this a s as a variable. Okay, dx by ds equal to u, and dt by ds equal to 1. Okay, dt by ds, so here, so dx quotient is u, and then du by ds equal to g. This is the characteristic system. Now, if we just take these two equations, du by ds and du by dx by sorry, these two, okay, du by ds and dt by ds. Okay, so these two if I take, so du by ds, so du by ds into ds by dt, that is equal to 0, because this is 0. So this is going to imply that u is a constant. Okay, u is constant. That means you have x of t, you have x of t, comma t is a constant. Okay, some constant is going. Okay. So now let us take these two. Let's take these two equations, du by ds and dx by ds. So in that case, what I'm going to do is that sorry, these two equations, dx by ds and dx by dt. So these two equations, if I take dx by dt, okay. So this is going to become like u by 1. Dx by ds is u, dt by ds is 1. So ds by dt I can write, so u by 1 is 1. So therefore we are going to get this is like x is equal to ut plus some constant is going to come. Because d is some other constant I'm going to keep. Okay. So ut plus t I'm going to keep. Okay, dx by dt is equal to ut plus t is equal to. Now in the case of x of t, okay, x of t, so this is going to be u of x comma 0 I'm going to keep it. Okay, so dx by dt equal to u is going to be that. So this I'm just going to at the initial time step. Okay, so therefore what I'm going to get is that I'm going to have x of t is going to become like, okay, x of t is going to be just now just I'm going to write this ut only right now. Okay, later change it. X of t is going to become like ut plus, okay, it's not u of t, ut plus d is going to become. Now at t equal to 0, what is it going to be? Okay, at t equal to 0, x of t is this one. Okay, when t equal to 0, what is it going to come? This is going to imply x of 0. I don't know what is x of 0. Some value will be there. This is going to become 0. Okay, this is going to become 0 equal to d is going to come. Therefore, what I am going to have is that this x of t, I can write as x of t is equal to u of ut plus x of 0 I can do. Okay, ut plus x of 0 I can do. Now what we are going to do? We are going to obtain the I'm going to use this initial condition. Is going to be okay. I'm going to use this initial condition, and then let us see what is it for this x of t equal to d. So in this case, what is it going to become? X of t is equal to okay, ut when x is less than 0, when x of 0 is less than 0, when x of 0 is less than 0, what we are going to have is that we are going to have t this place we are going to have, okay, t u of x comma 0. So this place I'm just replacing here. X of t is this, I'm just writing c is equal to u of x of 0, because why I'm writing that because what I have is that our u is going to be constant. Okay, this u is from this one du by dt equal to so this implies u is equal to c was there. Okay, I can use the initial conditions, whatever I have, u of x of 0, 0, I can use it. So this is going to be constant everywhere. Okay, the c u is going to be constant everywhere. In particular, we know what is u of x of 0, that is going to be that. So therefore, what I am going to have is that the c is going to become like u of x of 0, 0 is going to be. Since c is equal to u of x of 0, 0, u is going to be u of x, 0, 0. So therefore, wherever I have u, that place what I can replace that I can replace with u of x of 0, 0. Okay. So therefore, this can be written as x of t is equal to not only u, because of this condition, I can write it as u of x of 0, 0 into t plus x of 0. Wherever u was there. Okay, wherever u was there. That's what I have written. Okay. Now what I am going to do, I am just going to find what is my x of t. X of t is going to be when x of 0 is less than 0. When x of 0 is less than 0, okay, using this condition, what I am going to have, I am going to have u of x of 0, 0 is going to be 1. Okay, u of x of 0, 0 is going to be 1. Therefore, t plus x naught is going to be. T plus x naught is going to be. Because u of x of 0, 0 is 1. When x of 0 is greater than 0, when x of 0 is greater than 0, so this is going to become like 2. So 2 into t, 2t plus x naught is going to be. Okay, because this x of t is depending on x of 0 and t only. Okay, so x of 0 I know, for this initial condition I know, x 0 less than 0, x greater than 0 I know. So x of 0 less than 0 means I am going to get these values. U of x, 0, wherever is that, I am going to get this. Now we can solve this equation. Okay, we can solve this equation. What you are going to have is that you are going to have, so this x of t means x. Okay, I can simply replace x. So t equal to, so if I solve these two equations, okay, t is equal to x minus x naught is going to come. Okay, first these two equations. Then x of 0 is less than 0. And this one is going to be 1 by 2 into okay, t I got right. So x minus x naught. So x minus x naught. 1 by 2 into x minus x naught. So x of 0. Okay. Then x of 0 is greater. So t is going to be this one. Therefore, now if I write this, if I plot this curve, okay, if I plot this t against x naught, let us plot t against x against t, t against x naught. What you are going to have is that you are going to have straight lines. This is a straight line only. Either you take this equation or this equation, both are kind of straight line only. Okay, this is x equal to t plus x naught. This is a constant value. Here the slope is 1. Here the slope is 2. Okay, or here if I take, here the slope is 1. Here the slope is 1. Okay. So whatever equation take, we have to plot a curve which is going to be x against, okay, x against t and x against t. So here x, so in this case, so I just split that into here. Okay, so this part I am just putting it as 0. This is negative part. This is positive part. Okay, when x is greater, because my value changes depending on the x changes. So in this case, when x is less than 0, what you are going to have is that you are going to have slope plus 1. So I'm going to have something like this one. Okay, like this one. Now when x is less than 0, sorry, when x is greater than 0, when x is less than 0, you are going to have half as the slope. Okay, when x is greater than 0, you are going to have 1 as the slope. Okay, so you are going to have 1 as the slope. And this you are going to. Now what it is going to come is that, so when you are writing this one, okay, so correspondingly what you are going to have is that whenever you write this equation, you are going to have something like this way. Okay, one is going to be this way. Okay. Then one is going to be from here, starting like this. Okay, so other one is going to going like this. Therefore, what happened to this place? Okay, so if I just take only two, okay, only one curve, there will be plenty of characteristic lines to come. So let us talk about only one characteristic line. Okay, so let me remove the rest right now. The same thing is going to be applicable for the also. Okay, let us take these two lines. Okay, when x is greater than 0, what you are going to have is that you are going to have a straight line like the slope is going to be this slope I am just going to scale. Slope is 1. Okay, this slope I'm going to have after testing. Now what it is going to have is that you are going to have a gap between this one. So what will happen in between this one? For example, when my x comma t is, see if x comma t is this point, x comma t point, if I take it, if it is this one, I know where it is started from. Okay, I know where it is started from, so I can write it. When this is over here, I can find where it is started from. Now my x comma t is somewhere here. Okay. What is the value corresponding? Okay. What is the value corresponding to that? Because I have to find u of x comma t for all x comma t. Now x comma t is in this line, then I can find. If my x comma t is somewhere here, what is it going to come? Which we don't know. So those places I'm just filling with something called the dotted lines I'm filling, right? So this place I'm just filling with blue color dotted line. So those I'm just filling the artificial, which we will see in the later part of the lecture, how do we fill. So that is called R-gauge condition. We'll discuss about that later, because for which we need weak solutions, etc. So those part we'll discuss that. So this phenomena, what is happening is that one slope is having a one slope, another is having a half a slope. Therefore, in between some places, we will not be able to determine what is the value is going to be. Okay. So the flow is happening. The UP plus Ux is something happening in the flow. Either it's a traffic flow model or some other model. What is happening? I want to observe what is the of x comma t at all the position. But here I don't know what is going to happen, because I don't know what is the characteristic line corresponding to this x comma t. That means you cannot find the values of the position exactly. Okay, so that means you need a different technique for that, which we'll see later part of the lecture. So the characteristic lines corresponding to this equation, there are two families of characteristic lines are going to come with the different slopes, not same slope. We are going to get a different slope. So that is going to give us a trouble. Let us see what is the trouble is going to come. So the waves originating from x of 0. Okay, so the x of 0 is greater than 0, which is going in the right side much faster. Okay, it is going to move much faster than the waves it is operating from here, because this is going to travel a little slower, whereas this is going to go much faster, because this is going to reach that distance very fast. Okay, so the x of 0 move right. It is going to move right very fast compared to the base it is starting from here, because whenever it starts here, so it is going to reach very lesser time. So that means what you are going to have is that you are going to have a gap here. This is the gap I'm getting. So this is going to introduce a gap for us because of the slope which we are having. Here we are having the x of 0 is having a higher slope. Okay, so that's what we have. You see here. Okay, so x of 0 is x of t comma 2t. You can see that is having 2t, whereas the other one is having t only. X of 0 greater than 0 is having a slope as 2, whereas x of 0 less than 0 is having a slope as 1. So in this case, you can see that. Okay, in this case. So this is one slope, this is two slope. Therefore, that is going to move much faster. So therefore, what you are going to have is that you are going to have a gap here. So if you have a gap, what you are going to have is that the right one will be moving much faster, the left one will be moving much slower, whichever is. So that means in between there are no characteristic lines passing through this origin. This origin, there is no characteristic lines. Why this is happening? Because we have a discontinuity here, which is a jump discontinuity. Okay, there is a jump discontinuity at x equal to 0. Due to that, this is going to happen. Okay, so this is the problem which occurs in nature, especially in the atmosphere, etc. Okay, so this is one set of equations. So in that case, how do we solve that? Okay, how do we obtain the solution? There will be more detailed discussions will be in the later part of the lecture, but the idea will be how are we going to do it? Suppose in this line, how are we going to do it? That infinity many characteristics. Okay, there are many infinity characteristic lines starting from the which we are going to say, which is ranging from so 1 and half, okay, half and 1. That's a slope which we are going to do. There will be between half and how many points are there? Between half and 1. In this interval, how many points are there? There will be countably infinite number of points. Sorry, uncountable number of points are there. Okay, there are uncountable number of points are there. So I can ask my imagination. So suppose I want to fill this gap, I can take any straight line whose slope is between 1 and half and 1. I can take between half and 1. I can take any slope which is going to be taking that straight line. So In particular, what I'm going to do is that, so the proper way, how are we going to notice this one is that, I'm just going to see what is going to happen. Let's see, what is going to happen if x of 0 equal to 0. Suppose x of 0 equal to 0. In that case, what we are going to have is that, we are going to have, this is going to become like, x of 0 is going to become 0. So this one I'm just keeping it as it is. Okay, u of 0, 0 is going to come. So this one, from this one, what I'm going to have is that I'm going to have u is going to be x by t is going to be. Or I can write x is going to be ut is going to be, because x of 0 equal to 0 I have taken. Therefore, this is going to become like x equal to ut is going to come. Therefore, u equal to x by t is going to come. Now, what is the slope in between? Okay, in between, what is the slope is going to come? So in between, what is the slope is going to come? So this one, the slope is going to be 1. This one, the slope is going to be between these two. In between these two means whenever the x is between this t, because x of 0 is 0. In this case, this is going to be 0. Therefore, x is going to be between t less than x less than 2. That means it is going to be in between. In between is going to be there. Because x of 0 less than 0 means this is going to be here. X of 0 is greater than 0 means it is going to be 2t. Now x of 0 equal to 0, we don't know. We don't know what is the value of the t is going to be. Because we have infinite number of slopes, the lines, whatever you want to take, you can take as this between the slope. Okay, so that means your x is going to be lying between this t and 2t. Okay? X is going to be lying between this 2 and 2. Therefore, what you are going to have is that you are going to have your u is going to be x by t. Okay, u is going to be x by t, where t is t less than x less than 2. X is lying between t and 2. Okay, so the x is lying to t, then your u is going to be x by t. So in particular, I can just put this one together. How am I going to put this there? So I can just write this together as one solution for c of x comma t, which I will write it at the end with the explanation. So this type of base, where we are having some kind of discrete exercise, this kind of base, okay, which are decompression. Compression means this is opposite. Graph action is kind of decompression. Okay, so it's going to occur as a decompression, or it is called as a Rath action. Okay, which is going to fill the increasing gap. There is a gap which I am going to fill it. So this phenomena, or this type of phenomena is called Rath action. Okay, because this wave is traveling at a different speed. This wave is traveling at different speed. Okay, two waves are traveling at different speed. In between, there is a gap which we are filling. Okay, so this phenomena, this increasing the gap formed between these two, which you are filling it, this third phenomena is called Rath action. Now, if you put all these things together, okay, so what you are going to get is that when x is less than t, okay, this is going to become like when x is t of x comma t, I am going to write it. When x is less than t, you are going to have 1. Okay, when x is greater than 2t, you are going to have 2 because of this one. When x of 0 is greater than 0 means automatically get that x is greater than or equal to x is greater than or equal to t, you are going to get this 2 as the answer. X is less than t, that means it is falling in this one, so you are going to have this one as the answer. Now, in between these two, what you are having is this one. This is going to be explained. X less than. So we filled all the gaps. Okay. So that is only this possibility. If x is less than t, we will have 1. When x is greater than 2t, we will have 2. If it is in between, we will have x. Okay, so this is the gap. Any questions? Any questions? Any questions on this one? Okay. Okay, so the same problem, we'll solve it with the stock base again. Okay, so that is called another problem. Stock base. I'm just going to change the phenomena a little bit. Now, what I'm going to have is the same kind of problem, but with different condition. Okay, ut plus ux only I'm going to take it. But now I'm going to take it in a different. So now I'm going to take next problem, stock base. So here I'm going to take same further situation. I'm going to take with different condition. The condition is 2 x is less than 0, and 1 if x is greater than 0. So earlier 1 and 2 was there, now 2 and 2. Okay. So this is completely opposite to Rarfaxon base. What you are going to have is that you are going to have a u of x comma 0 equal to 2 means u is velocity. Okay. So that means it is going to move faster. The left side is going to move much faster. Right side is going to go much slower. Okay. In the earlier one, in Rarfaxon, you can see that left side is going to be slower. That is the reason you are having a line which is having a high slope, and right side you are having half this faster slope, or the other way. So that means your u is going to be going much faster. Okay, on the right side it is going to be much faster. Left side it is going to be much slower. The Rarfaxon. Now in case of soft base, what we are going to have? We are going to have left side is going to be much faster. Right side is going to be much slower. Okay, compared to this one, 2 is greater than 1. Therefore, the left to right is going much faster, whereas the right side is going to be much slower. Okay. So in this case, what is the characteristic line? Same phenomena, whatever you have solved. Okay, so we are going to have x of t. So what if we solve? Same equation. I just repeat you one more time. Same phenomena. Okay, whatever you thought. So what you are going to have is that du by dt is going to be 0, which implies u is going to be constant, which implies in particular I can put any constant. Okay, so c equal to, but I got the initial condition, therefore it is going to u of x comma 0 comma 0 is going to come. Okay, now again dx by dt equal to u is going to be there. So therefore you are going to have x is equal to u of x of 0 comma 0 into t plus d square. Okay. Now what I have x equal to this one. Okay. So what I have x of t is going to come. So x of t is going to become like. So I got to use this condition now. So x of t is going to be u of x comma 0 comma 0. When x of 0 is greater than 0, we are going to have 2t. Okay. So this t is again it is going to become like x of 0 as I have seen in the last one. X of 0 is going to come. So x of t is going to come like 2t plus x of 0 is going to come. Okay. If x of 0 is less than 0. And next one, it is going to become like when x is greater than 0. When x is greater than 0, what you are going to have is that you are going to have t plus, okay, this is going to become one side. Okay. When x of 0 is greater than 0, you substitute here. We have x of 0 is going to be 1. So therefore this is going to become like t plus x naught is going to come. Okay, x of t is going. So again you can solve for this t. So t is going to become like, you can write it as this time it is going to become like half into x minus x naught. To solve this one. Okay, half into x minus x naught, and this is going to become like t minus x naught. Okay, and x of 0 is greater than 0, and x of 0 is less than 0. Aside. Okay. Now what is going to happen? Let us draw the graph again. So in this case, again we are going to get a two characteristic family is going to come. Now this 0 is here. Okay, x is here. So let us forget about this one. So t is going to be that. So what you are going to have is that you are going to have, this is going to come here. Okay, this is going to have a high slope. So you are going to have like this one. Okay, like this is. So that means what we are having the problem now is that in this case, suppose I'm sitting in this intersection plate. This intersection line I'm having. Now the question for you is that I want to trace back. Okay, so let us consider one curve. Okay, plenty of curves. Okay, so that I will ask the question. Then you can just tell me where it started also. Okay, so suppose I have a slope here. I have a slope here. Okay, let me see. Let me draw with the other color. So this is one characteristic family. Another is another characteristic family like this. Okay, like this I have. Okay, so. Okay. So like this I have. Now, if I am just sitting in this plane, this is my x and this is t. Suppose this is my x comma t, I can clearly say that where I started from. So I got started from this location, I can say. Okay. Now suppose this is my x comma t. Then I can say where I started, where the curve started from. Okay, where is the back trace? Okay, back trace, and I can find out where this was started from. I can locate where the curve started. Now suppose this from here. Okay, in this intersection. Now the question is, suppose this is my x comma t. Now the question is where the curve started from. Whether it started from the black color or green color. That is the question. In this intersection, you will get some problem because you will not know where it started from. Whether it started from here or it started from here, that is not known to you. That means you will be getting some trouble in this case because you don't know how to back trace them. Okay? The back tracing is not possible in this case easily because both are this can go to this one or this can go to this one. So that means you will not be able to back trace. So that means your U is going to become like multi-value. So U is going to become like multi-value function is going to become. Okay, because I can find one U corresponding to this characteristic line. Again, I can find another U because if I back trace here, we will get another characteristic line. So whether after this one also whether it should go here or here. Okay, suppose you locate it here, you just solve this problem. It is some time different problem you solve. After this one, where do you? I will explain with some examples also. Okay, with the practical example, why it is going to be very important. Because when I reach here, what will happen is that your system will get confused whether it should reach here or it should reach here. So this is due to again the discontinuous problem. So due to the discontinuous, you are going to get that. Because U is going to become like multi-value, so it will not know whether it has to go here or go here. So that means it will be a problem. Okay. Now imagine that such a situation is going to arise in some of the problems in space shuttle or something. So that is going to be a big problem, which I will explain with videos. So the characteristic lines originating from x of 0 greater than 0, less than 0 is have smaller stroke. This is having a smaller stroke. So therefore, what it is going to have, this is going to touch this one. Therefore, we are going to get some intersection here. This intersection is always possible in this case. Okay. So this leads to a problem, as I mentioned. You cannot back trace where it started from. Okay, you cannot trace back where it started from. Correct characteristic value. For example, from here, I don't know whether it follows this characteristic or this characteristic at this location. Okay, this problem will be. So this phenomena is called sockets because you don't know what is going to be there. So in this case, you are going to have a multi-value function is going to be. It is going to be multi-value. So this happen. Okay, the faster moving wave catches the slower moving wave and form a multi-value. So these are all some of the examples of the surface. For example, when you unburst it, okay, with some pin or something, then you can say that there will be a immediately will just some pop up. It will just make some sound, big noise. So that is going to be a soft tube problem. That is kind of a soft tube problem. And when you make some TNT explosive, okay, high explosive or TNT explosive, at that case also, we are going to have this kind of soft basis. Similarly, there is a bow suck that is carrying space shuttle, and supersonic waves also is going to be. So let me show the videos for you. What are the things which is going to happen? So for example, you can see this one, shockwaves in plane. Okay, so this video you can see that. So there, this is going to have, this is a supersonic plane. Okay, in the supersonic plane, once again, this kind of phenomena is going to occur. So you can see that this is a shockwave problem where the flight is going at a certain speed. When the speed is increasing, okay, when the speed is increasing means per second, if it is reaching more than the speed of the sound, then always you will get a sound. So this is okay. This is, you can see that white patches here. This white patches, it is moving along. Once it reaches the tail of the things, what it is going to happen is that it is going to produce some kind of shock. Shock wave begins to forward, aircraft's trailing edge. The trailing edge, it is going to happen. So this is going to make a phenomena which is going to make some kind of oscillations, or it can just collapse that system also sometime. So the aircraft should be designed in such a way that this is captured properly. This arc wave is captured properly and it has to be balanced. Otherwise, your the speed will kill jet or the plane very quickly. Okay, so this is one such arc wave. You can watch this video. Then another one is supersonic bullet. Again, same kind of arcs will come here. Okay, so you can see that at the end, at the beginning, you can see that there is a curved one is there, right? So this is kind of the arc. So at the trailing, you can see that. Okay, the trailing, you can see that there is a arc forming here. So there is a arc forming here. Okay, so two intersection, you can see that two intersection is happening. So in this place, you don't know like where it started from. Okay, so that is another one, arc wave. So pressure field. So you can see that such kind of arcs are coming. Okay, so arc waves they are explaining. See that from where it started, it will be difficult for you to judge. Okay, this is one more arc waves. Then this is one more paper actually. Okay, this paper actually explained how the death of Kalpana Chawla, one of the Indian origin scientists, she went to space shuttle, right? So here also same kind of thing, because when the space shuttle is moving from the Earth, there will be problem, which I have shown you like how the bullet or how the space, how the flight is going. Now same thing, suppose the space shuttle is entering the Earth. If it is entering the Earth also, it has to reach the atmosphere and then it has to sustain it. Again, in this case also, what will happen is that when the space shuttle is re-entering, there is something called re-entry shuttle, re-entry physics. Okay, so in this case also, what will happen is that this is going to produce some kind of shocks here. You can see that there is a shock wave they have mentioned here. This shock wave is going to make it will make the temperature very high. Okay, once there is a shock wave here, it will make the temperature very high. It will reach about more than 1600 degrees. So due to that, if you don't make that space shuttle structure properly, what will happen is that will also produce a shock wave. So you can see that. See, this is by they redesigned that. One of the ways to accomplish this designing by nose cone, such that the shock wave is pushed from the away from the vehicle. That means there is a shock wave formed already. So if you don't design your space shuttle in a proper way, what will happen is that shock wave will kill this space shuttle completely, and then you are going the death can occur. So this is due to that shock wave only. This space shuttle, this astronaut Kalpana Chawla died. Okay, that is due to the. So this is one more thing. So you can view this article also by Kalpana Chawla's death, last flight. So here also they might have mentioned about the shock waves. Okay, how does it happen, etc. Okay, so this is also another thing which you can refer it. One more thing, two more thing actually. So shock wave interaction also will happen, which is from a NASA paper. You can see how the shock waves are occurring and how that is going to play a significant roles in supersonic flights, etc. Okay, so this you can check it. What is the thing? So this is one of the important phenomena in the space shuttle and other things. One more paper. This is in the traffic flow, because the Pargar's equation we derived from the traffic flow model, right? So here also you can see the shock waves interactions over here. Okay, in this paper also they have mentioned about shock waves. So you can check it. Okay. So here also they have mentioned about the shock waves, so you can check it. This paper completely discusses about what is the shock waves occurring here, etc. Okay, there are plenty of keywords you can see there. Okay. So these are all the important application of this shock waves, which is still an emerging hard research topic where you can solve some of the problem. Okay, because this discontinuity, because of this discontinuity, not only this kind of discontinuity. So in general, you can take the initial condition of x comma 0. Later part you will see that at the end of this course almost you will see that. So you can say like some UL and UR. Okay, when x is less than some t and x is greater than t, or t not taken. So in this case, left is there, right is there. So you can put like different conditions. You can put either UL less than UR, you can put it. So in that case, you will be the Rahr fraction. If UL is greater than UR, you get the shock waves. So this condition we will see it later. In this case, we need to define something called RH condition. Okay, so those conditions we will see that, and we will have some kind of problem called Riemann problem also will occur. So for this, some more knowledge about this PDE is required. So therefore, we will push it at the end of the lecture to discuss how to solve this kind of. So this kind of problem is again occurring in many of the cases in the astrophysics also, where suppose some supernova is blasting. Okay, suppose some asteroid, or like how the Earth has formed or the planet has formed. So in that case, some supernova or asteroid just hitting the Earth's atmosphere, etc. In that case, also similar kind of surface problem. Okay. So we'll see more details about this in the later part of the lecture. Right now, we'll go to the other thing. Okay. Let us see. Chart is that and these things we'll see. At that time, we'll discuss once again the same problem. Okay. Okay. So now let us go to this is another problem where you can solve this perverse equation for this given initial data. So e of x comma 0, you can take 1 if x less than 0, and 1 minus x if x belongs to 0 comma 1, and 0 if x greater than 1. Okay. Similarly, another problem also you can solve. Okay. So instead of 2 1 here, I'm putting 1 0. So therefore, this will be tricky because 0 is there, so you have to check it like how the condition is going. Okay. So these two problems I will give you as an exercise. Okay. Now let us go to the next topic where we are going to solve general solution. Okay, we have the quasi-linear PDE, right? What is the? Could anyone tell me what is the general quasi-linear PDE format in 2D, 2 variables? What is the equation format for general quasi-linear PDE? 2D variable.
So AUX plus BUY is equal to CX. C.
Yeah. So this is the general PDE format. Okay. Okay. So this is the general quasi-linear PDE. Now for this problem, we are going to solve the equations. Okay, we are going to solve this equation and finding a general solution function. How do we find a general solution function? Let us see that. Okay. So let us consider a point P of x comma y comma u in omega. Omega is the domain, and let us take a characteristic curve. Okay, we are going to take a characteristic curve. I'm going to take this characteristic curve gamma such that x equal to x of s, y equal to y of s, u equal to u of s. Okay. Suppose this characteristic curve, okay, can be represented by intersection of two surfaces. Suppose there are two surfaces, S1 and S2. S1 and S2 are there. These two surfaces intersection is going to be this characteristic curve. That means what? Gamma is nothing but S1 intersection S2. If I take this intersection of these two surfaces, I'm going to get this curve. Suppose the curve. Now what I'm going to say, suppose S1 is represented by this one, okay, some function, because it is a surface, I can represent like this, x comma y comma u equal to some C1, and S2, I'm representing as some other variable, psi of x comma y comma u equal to C. Okay. So here, what we are having is that we are going to take n pi and n pi means the normal derivative. Okay, normal derivative means I have a surface. For this, I'm taking a normal derivative. Okay, tau pi by tau n I can take it. Suppose this is my pi, tau pi by tau n, or I can write as n pi. Okay, so this is linearly different. So tau pi by tau n and tau pi by tau psi by tau n both are linearly different. Okay, at this point x comma y. So these are the conditions I have. Then what I'm going to do is that I'm going to derive a general solution for this problem. Okay. So here, as I mentioned, this is going to be n pi means n pi is nothing but this one. N pi is a function of pi x comma pi y comma pi u. Similarly, n psi is going to be n psi of psi x, psi y, psi u square. Okay. So now a continuously differentiable, okay, continuously differentiable function, this function pi of x comma y comma u is called said to be first integral. This is called as a first integral. If it is constant in this characteristic curve. In this characteristic curve, suppose this I'm getting. For this problem, let us say this is the problem number 7, as I mentioned there. For this problem, a continuous differential function pi of x comma y comma u equal to c1. Okay, so that is said to be first integral of this equation. If it is constant in this characteristic curve, it should be constant. Then it is called as a, so this kind of integral is called first integral. Okay. Now suppose there are two first integrals. Okay, this is also first integral. This is also first integral because here also it is going to be c1. Here also it is going to be c2. Okay, the condition is that any differential function, if we take in this characteristic curve, then it is going to be there. So in this case, pi of x comma y comma equal to c1, pi of x comma y equal to c2, both are first integrals. Okay, suppose there are two first integrals. Pi and psi are two first integrals. Okay, then we say that these two functions are functionally independent if rank of, we have to calculate the rank of pi x, pi u, pi y, pi u, psi x, psi y, psi u. Okay, it should be 2. The rank of this one should be 2. Okay, that means what? I have to find what is my n pi and n psi. Okay, that is same as saying n pi and n psi is linearly. If these two are linearly independent, automatically this rank is going to be linearly. Let us see that with much more detail. What do they mean? That means what they are saying. So n pi and n pi are pi x and pi u. So these are all the rank is 2. That means what we are trying to say is that, see, it is given that pi is a function of x comma y comma equal to c1. So along the characteristic curve, gamma recursion. Okay, so let us say c1. So gamma is nothing but x equal to x of s, y equal to y of s, and u equal to u of s. So for this one, I can write as pi of x of s, y of s, u of s equal to c1. So now I take the partial derivative of, I take the total derivative of this one. So this is constant. So if I take the t pi by ds, okay, so for this one, if I take t pi by ds, this will be 0. With respect to s, this will be 0. So what is t pi by ds? Actually, t pi by ds is it's a function of this one. So pi x into this one, I got the derivative dx by ds, then pi y into dy by ds plus pi u into du by ds equal to 0. This is nothing but a total derivative. If I take the total derivative, since it is constant, with respect to x, if I take the total derivative, it's equal to 0. So that's what I got it. Same way I can apply for the psi of x comma y comma u equal to c2. Okay. In this case, it is going to become like psi x dx by ds, psi y dy by ds, psi u du by ds equal to 0. Okay. But what is, see, this is our problem, right? A of x comma y comma u ux plus b of x comma y comma u into dy. So for this one, what is the characteristic system actually? The characteristic system is that dx by ds equal to a, dy by ds equal to b, and du by ds equal to c. Okay. So therefore I can substitute those over here. So this is going to be like pi x into a. Okay. So a means a of x comma y comma u. Okay. Pi y into b. Similarly, b means b of x comma y comma u, and pi u into c. C means this one. Okay. Similarly, psi x a, psi y b, psi y psi u c is 0. Is also 0. Okay. So these two are functionally dependent. Okay, these functions pi and psi are functionally dependent. If and only if when it is going to happen. So that means if it is functionally dependent, what we are going to have is that we can solve the system. Okay, solving the system means we are going to have a divided by, okay, so a divided by, calculate the determinant of the rest of these. Please forget about this row. So it is going to become like pi y and pi u psi y psi u. Okay, this should be non-zero. Then only you will get that rank equal to 2. Okay, at least some of them is going to become 0, and you will have it. Similarly, b by, so forget about this one. We are going to have pi x, pi u, psi x, psi u. Okay, you write it in the other way. Doesn't matter. Similarly, C by what about this one? So here I mentioned because usually the determinant will be mentioning the change of this right second one, so that's the reason. But it is it doesn't matter. Pi x, pi y, psi x, psi. Okay, so this is going to be your if this is going to be there, this is going to exist. Pi and psi are really functionally dependent. Then the first integral of the first integrals, okay, depend on if this is going to be satisfied. Okay, so this is the condition. Let us see that how we clear, right? This one. Okay, so from this one, what we are going to do is that these conditions we are going to use it and to prove the to prove some theorem called general solution. Okay, what we are going to have is that I have pi x and psi. From these two equations, I need to obtain a general solution, which is going to be some pi f of pi of x comma y comma u and psi of x comma y comma u equal to 0. This is my general solution. We'll prove this theorem. Okay, how do we obtain? Suppose, so the theorem statement is as follows. Suppose pi of x comma y comma u equals c1 and psi of x comma y comma equals c2. Both are two independent solutions of the ODEs. That means what? So two independent solutions of this ODEs means what? So this is going to be satisfied. This condition is going to be satisfied. Okay. So that means it is going to be satisfied. This one. Either dx by ds you can use or dx by dt. Okay, because this is just a parameter or dummy variable I can say. Okay, so therefore either you can it as dx by ds or dx by dt doesn't matter. Okay, for this time. Okay. So dx by ds equal to a, dy by ds equal to b, or dy by ds equal to c. This is the characteristic ODEs for this Gaussian E. Okay, so for this these two are two functionally two independent solutions, okay, of the system. With the condition that what I call the condition is that I have pi u square plus psi u square not equal to 0. Okay, this condition is also pi u square plus psi u square. Then the general solution of this equation is given by this formula, where f is an arbitrary. You can take any arbitrary function and substitute this one, then you are going to get a general solution for this thing. Okay. So let us prove this theorem. How do we obtain? Yeah, we got to use this thing. Okay. So we'll prove one part first, then we'll do the second part. Suppose what we have u equal to x comma y comma u is a function which is satisfying this one. Okay, u of x comma y is a function which is satisfying this condition f of so u equal to u of x comma y is satisfying this one. Therefore, what you are going to have f of pi of x comma y comma u of x comma y of x comma y comma u of x comma y equal to 0. So u is a given like this. Okay, u equal to the function for which this is satisfied. Now, if I differentiate this one with respect to x and y, what I am going to have? I am going to have f pi, okay, and differentiate this one pi x, okay. Then you have this is function of again pi u into ux square. Okay, that's this one. Pi f pi into pi x. Okay, this is going to be here. F pi is common here. F into pi. Then pi I got to differentiate with respect to x. So pi x plus pi u into x. Plus again psi we are going to have f psi into pi x, psi x into ux, ux psi u. Okay. Same way, differentiate with respect to y, we are going to have f pi y plus pi u into 2y plus f psi into psi y plus psi u into y. Okay. Suppose f pi and f psi are not equal to 2. So these two are not equal to 2, not simultaneously. Then what we are going to have? So if these two are not simultaneously 0, that means you can solve this system. If you solve this system, what you are going to have? if this is going to be 0, suppose these two are not equal to F5 and Xi are not simultaneously 0. Then in that case, what is it going to come? This is going to be this determinant. So if I write this one in the determinant form, what I will do is that I can write it as a matrix format. Okay, pi x plus pi u dx, psi x plus psi u into uy ux. Okay, and this one pi y plus pi u into uy, psi y plus psi u into uy. Okay, then this one I can write as f pi f psi. Okay, equal to 0. And in terms of matrix form. Now this is not simultaneously 0. That means f pi and f psi is not simultaneously 0. Okay, in that case, what we are going to have, what we are going to get is that we are going to get this is equal to 0. It is given that this is not equal to 0. Therefore, this is going to be this determinant of this one is going to become 0. Okay, this determinant is going to be 0 means so I can just write it as this determinant. The determinant of this one is going to become 0. Okay, this is going to okay. If this determinant is 0, what are we going to get? We'll just expand this one. Okay, if I expand this one, what I'm going to have? I'm just going to expand this one, then I'll just simplify this one. So pi x, okay, so I'll just multiply here. Pi x, so I'll take the ux component. Okay, so ex component, I'm going to get pi u into psi y, pi u into psi y, pi u into psi y. Then what I'm going to have? I'm going to have here again another ux is there. So pi u into psi u is pi y into psi u is going to come. Okay, pi y into psi u is going to come. I take the ux component. Okay, so the ux component will come this one. Okay, and multiply this one with this one. Pi x multiplied with pi u multiplied with psi y, and pi y multiplied with psi. So that is multiplied. Similarly, so you make a simplification. Okay, you make a simplification, and then obtain these values. Similarly, you can get that. Okay, pi y. So I write that. This I was simplified already. So this one as it is. So pi x into psi u minus pi u into psi x. U is going to remaining things are going to be on the other side. So you are going to get pi y into psi x minus pi x into psi y. Now, if you compare this equation with this one, what you are going to have is that you are going to have pi u. Okay, so pi u into psi y minus pi y into psi u. Okay, so here this one, that is this is ax comma ux system. So the coefficient of ux here is this one. The coefficient of ux is this one. Because we are saying this is going to be solution of this one. Therefore, whenever I expand this one, this should satisfy this one. Okay, this is going to be satisfying this one. That's what we are comparing. So that means what we are going to have, if you compare this one, pi u minus psi y minus pi y into psi u, you are going to get that. You are going to get aux plus py and cy. Exactly, you got a similar kind of equation. Okay, so you can just check that. Yeah, so this one you can see that. See ax comma y comma u divided by pi u minus. Okay, so you can see that pi u minus psi y is there, and psi y minus pi u pi y minus psi u is okay, pi y minus pi y into psi u minus psi y into pi u is there. So that is going to be there. Okay. Similarly, px term you can compare that. You are going to get this one. Cx term you can compare that. You are going to get. Okay. So that means what I got is that I started with some arbitrary function with e equal to d of x comma y, and then I take the derivative and I assume that this is not equal to 0. In order to satisfy this one, it has to satisfy this one. If this is satisfying this one, automatically this is going to be satisfied because these two are solutions of the integrals. Pi and psi are first integrals, functionally independent. Therefore, it should satisfy this condition number 9. That implies that this is same as this one. Okay. So if it is a solution, this is a arbitrary function, this first integral of these two, then automatically you are going to get this equation. So I mean, I reverse transverse back. Now the other part also will do that. Okay. So now what I am going to do is that Converse part. Suppose U is a solution of 7. Okay, U is a solution of 7. That means what I'm going to have pi of x comma y, pi of x comma y comma u, psi of x comma y comma u, both are functionally independent integrals of this one. Okay, therefore, what you are going to have by this equation, again you can obtain this equation. From here, you can obtain this equation. You solve this equation. We have x comma y comma u and solve these two equations. Once again, what you will get is that you are going to get the equation number 10 is going to be. You solve this equation. This either you take the equation number 9 or these two equations you can take. Again, you can solve them. Again, you will get a similar kind of equation number 10 is going to be. So that means you are going to get the answer. So we have what we are going to have is that in this case, the converse part what we are going to have is that you are going to have something, let us say pi, capital pi equal to pi of x comma u is going to be there, and capital psi, okay, it's going to be psi of x comma y comma u, and it's going to assume that. Again, if fi and psi is not equal to 0, again repeat the same thing. Okay, fi and psi is not equal to 0. And in this case, again you can do the same kind of thing. So psi x, capital pi x, capital pi y, capital psi x and capital psi y. That is for the same thing. You obtain this one. Then what you are going to get? You are going to get pi x. Simplify this one. Since this pi and u is satisfying this conditions, what you are going to have is that we are going to have this. This is going to be satisfied. Okay, after simplification, what you are going to get is that you are going to get the simplification part. I will do this. So therefore, what you are going to get is that if these two are this is 0, then what you are going to have is that from the functional calculus of theorem, the rank theorem of calculus, what you can, or rank theorem also you can look it. It is going to say that one combination of functions. Okay, that means I can write pi as some function of psi, or I can write psi as some function of, okay, this can be some function of pi, or this can be some function of pi. Either way is possible. Okay, so I'm just taking the second way. I think psi can be written as g of pi. So therefore, what I'm going to have, so I can write it as implicitly saying that pi of psi comma x comma y comma u, capital, okay, and this one I'm just substituting, comma pi of x comma y comma u equal to 2. Okay, so that is the proof. Actually, this proof mostly, if you see some of the Indian authors, they may not give this one straight away. They solve this problem. Okay, so I'll just solve one problem and then we'll find the class. Second problem you can solve it on your own. So if you take any of the Indian author, straight away they will deal with this equation. They will straight away deal with this equation. They will take this equation. In fact, instead of ax comma y comma u, they will simply take this dx by whatever I have written down. They will take it as simply this one, and then they will solve it. Many of the Indian authors and even some of the foreign authors also. But the reason how we obtain this solution is that this general solution format, from that only we are obtaining. So for which I will solve one problem, okay, because this is the application part where we will be applying. I will solve one problem with example, then you can solve the rest. Similarly, what you need to do is that you need to know like something like fraction mathematics. So let's take one problem: y plus 2ux into ux, sorry, 2ux minus x plus 2uy into y equal to half into x square minus x. Let us solve this. Initial conditions given is that gamma equal to x equal to s, okay, y equal to s, and u equal to initial condition. Okay, this has exactly one solution that we have used. So again, I can take the characteristic system dx by dt equal to y plus 2x, dy by dt equal to. So here T or S doesn't matter. Okay, some places are implementing T, some places are implementing T, U, S. Okay, so that doesn't matter because that is just dummy variable. T by dt equal to half x. Now we got to solve this characteristic system in order to obtain the solution. So how are we going to obtain the first integral? So I'll just take I'll just multiply this one, okay, with this x. Therefore, I'm going to get x dx. This one with y, so I'm going to get y dy. Okay. So in this case, what I'm going to have? I'm going to have xy 2uxy is going to come minus xy 2uy. Sorry, xy 2x square is going to come minus xy 2uy square is going to come. So I can take 2u common. Okay. Then we are going to have here x square minus y square is going to come. Okay, here equal to. Similarly, I'm going to do du here. Okay, 2 that is going to become x square minus y square. I can solve this one. Okay. So x square minus y square, x square minus y square cancel. So assume that the x is not equal to x square. Then if you solve this one, you are going to get x is equal to, so 2u du is that. So this is going to become like 4u. So 4u square is going to come. So this one I can plus some constant is going to come. Minus here equal to c1. I can write it. So that one I can write it as psi of x comma y x comma. Okay. So let me write it as phi of x comma y. So this is one surface I got from. One first integral or integral surface I found is the phi of x comma y. Now second one you can find it in a similar way. Okay, what I'm going to do? I'm just multiplying y dx plus x dy. So this part actually there is no standard way to find this one. You can just using your intuition, or you can just make some trial and error, like which one is going to make one of the terms 0 and making this one. So that way you can do it. So here I'm just multiplying y dx and x dy. So in this case it is going to become like y square. This is 2y. This is minus x square. And this is going to be minus 2xy. So 2xy cancel. So you are going to get y square minus x square square. Okay. Equal to here same thing du by 2 du by x square minus y square. Okay. So this is, I can just cancel it. The negative sign will come. Okay. So that's what you are going to get. Y dx plus x dy, you can write as p of x comma y, and this is going to be minus 2 du. So if I integrate, this is going to become like xy plus 2u. Okay. Equal to c2, I can write it. So this I am going to call the second function xy of x comma y equal to xy plus 2. So that means you got two functions, phi and xy got. So according to the general integral solution, what you are going to have is that you are going to have what you are going to have. See, you don't need to verify this one because we already obtained it using this formula only. Using this formula only you have obtained. Okay, this is if and only condition. So that is already satisfied. Okay, if you want, you can verify that also by your own. You can just whether psi x and psi pi are the denominator is going to be equal to 0. So therefore, this one I can write as x square plus y square minus 4u square equal to some g of xy plus 2u square. Okay, this is now next one. For the given term, you have to find it what is term. Okay, so if I put for psi for pi for c1, if I put this one, this is going to become like s square plus s square. So we are going to get 2s square equal to c1 is going to come. Okay, for the second one, if I substitute, in this case it is going to become like again s into s square is going to come. Okay, s square plus only s square is going to come equal to c2 square because c is c2. So 2s square equal to c1, s square equal to c2. For these two, what I can get? I can get c2 is equal to c1 is equal to 2c2. I can get c1 is equal to 2c2. Therefore, what I am going to have is that I am going to have a relation. Okay, so this place I can just replace it. Wherever c1 is there, I can replace by psi. Pi. Wherever c2 is there, I can replace with psi. 2 psi square. Okay, so therefore your equation is going to become like f of pi comma psi is going to become like pi minus 2 psi. Okay, this is going to be your equation. Pi minus 2 psi equal to this is going to be your solution. General solution. Therefore, what you can put, you can just substitute this one. So this is going to become like x square plus y square minus 4u square equal to 2 into xy plus 2. You simplify this one for u. Okay, simplify this for u. then you are going to get u is equal to half into square root of x minus y equal to square. So I leave to you as an exercise. Okay, this is good. So this is the only solution we are going to. You can verify it is satisfying the boundary conditions, etc. You can check them. We put x equal to s, y equal to s, this is going to be s minus s cancel. So here square root of 1 is going to come, 1 minus 1 again 0, so we are going to satisfy. Again, if you want to verify whether it is going to satisfy this equation, you take ux and uy and multiply this one and then check it whether it is satisfying or not. Okay, so that is also as an exercise. Same way I can solve this problem. Okay, I leave it to you. I'll just give this for you to explore. Whatever I have, it is fine or not. Same way I can solve this problem. Okay, and I give some exercise problem also, which also you can do it. Okay. So with this, I will stop the first order ODE for the moment. First order linear and postlinear PDEs for the moment. Next class, Wednesday onwards, we will begin with heat equation and separation of PDEs. Okay. So until the mid semester, we will cover this. Then we will go for the advanced topics. If you have any questions, let me know. You can write an email or you can WhatsApp me anytime. Thank you. Any questions? Okay, thank you.
Thank you, sir.
Thank you, sir.